So the chapter which we are going to deal with today is matrices. It is a part of algebra, and it's certainly very different from the chapters you have seen before, because you see numbers being arranged in a very specific order. Okay, and matrix can consist of many elements. It consists of rows and columns. Okay, so just briefly to describe matrix, a matrix is a rectangular array of number, symbols, expression arranged in rows and columns. A matrix can have one or more rows or one or more columns. A simple example of matrix could be 2 by 2 matrix, somewhat like this, 2, 3. Numbers can be positive, negative, or 0. It can also be fractions. So this here what I have drawn is a 2 by 2 matrix, where 2 means number of rows, while this 2 means number of columns. Okay. So can you tell what is the order of this matrix?
So 3 by 1.
3 cross 1. Okay. And what about this matrix?
1 by 3.
1 into 3. So it's always row first and then the column. So order of matrix is defined as m cross n, where m is the number of row and n is number of column. And here are some examples. What are the different types of matrix we have? So a row matrix is a matrix which has only one row. It can have any number of column. So the example you see here is a 2 cross, like it has 3 columns. So it is 1 cross 3 matrix. Okay, so this is one example of a row matrix. Similarly, a column matrix is a matrix with one column. So here we have a matrix 2, 5, 7 with 3 rows and 1 column. Okay, so these are called as column matrix. Similarly, a matrix which has equal number of rows and column. As you see in this example below, this consists of 3 rows and 3 columns. So this is an example of square matrix. Is this a square matrix?
Yes, sir.
It is a 2 cross 2 square matrix. Okay, and what about this?
Yes.
Even that is a square matrix. It is 1 cross 1 square matrix. Zero matrix. A matrix in which all the elements are 0 are called as zero matrix. For example, here you see we have a 3 by 3 matrix in which every single element of each row and column, in fact, every single element is 0. So that is example of a zero matrix. Clear? Next, we have a diagonal matrix. A square matrix where all off-diagonal elements are 0. What do you mean by off-diagonal? Okay.
So from top left corner to bottom right corner, whatever are there.
Yes. So see, in a square there are two diagonals, but we are talking about the principal diagonal here. According to matrix, the one which starts from the top left corner and goes till the bottom right corner. That's the principal diagonal. Those elements are not 0. Rest everything else is 0. Then it's called as diagonal matrix. Okay. Leaving that, everything else is 0. Okay. What if some of the elements are also 0 in the diagonal matrix, like instead of 1, 2, and 4, if it was 1, 0, and 4? Even that is a diagonal matrix. That also is a diagonal matrix. There is no restriction on the diagonal elements. The restriction is only on the non-diagonal, off-diagonal elements. Clear? Okay. Next is identity matrix. An identity matrix is a diagonal matrix where all the diagonal elements are 1. So the principal diagonal elements, unlike the regular diagonal matrix, can be any number. This is more specific. These are all 1. So it's 1, 1, 1. Okay.
Sir,
Yes.
so identity matrix is also known as unit matrix, right?
Yes. So a 2 by 2 unit matrix looks like this. Okay. This is a 3 by 3 unit matrix, and this is 2 by 2 unit matrix. Clear?
Yes, sir.
When do we say the two matrices are equal? Okay. Two matrices are said to be equal if their corresponding elements are equal. For example, here it's given that these two matrices are equal. It means every corresponding element must be equal. That means A is equals to -1. What about B here?
2.
B is 2. What about C here?
3.
And D?
7.
Okay, that's it. Let's try one quick question based on that concept, which we just learned. Okay, it's given in this problem. Okay, to find x, I can compare the first two elements. So x is equals to 3. What about y?
So y it will be -3.
Are you sure?
-1.
Not
No,
-3. It is
-2.
1 minus. So that is -1.
-1.
Okay. Okay. 3 is 3. So we leave that as it is. And in order to find z, we can compare this second row, second column element, the second row, second column element in the other matrix. So z minus 1 is equals to 2. So z is equals to
3. Z is equal to 3.
3. All right. So that was simple.
Yes, sir.
Let's try a few more. What is A, B, and C?
A is -3.
Okay.
Oh no, never. Oh yeah. B is -8.
-8. Okay. C is 3.
3.
Okay. So that's fine, right? So A is -3, B is -8, and C is 3. These answers are correct. Moving further to certain operations which are possible in matrices. First operation which is possible is addition. Just like normal numbers or algebraic expressions can be added, even matrices can be added. Matrices can be added if they have same order. Okay, so here we have this condition. We can only add two matrices if they have the same order. Here in this example, we see a 2 by 2 matrix getting added to a 2 by 2 matrix. Can we add a 2 into 3 matrix to a 2 into 2 matrix?
No, sir.
Okay, that's not possible. Okay, so we can only add two matrices if they have exactly same order. So here, let's try to add it. 4 plus -1 is
3.
3. -2 plus 2 is
0.
0. Okay, and 0 plus 3 is
3.
okay, and 7 plus 5.
12.
Okay. That's all. That's how we add matrices. So we just add the corresponding term to the of one matrix to the corresponding term of the other matrix. All right. Same goes for subtraction as well. Even in subtraction, we follow the same pattern. Okay, we subtract the element of matrix B from the corresponding elements of matrix A. So it's A minus B. So here also it's 3 minus -1 is equals to -5 minus 2 is
Minus
7.
7.
1 minus 3 is equals to,
-2.
and 5 minus 7 is equals to
Minus
-2 again.
-2, yeah.
Simple.
Yes, sir.
Okay. Next concept. Can we multiply a matrix with a scalar? When we multiply a matrix with a scalar, it just means that you multiply that constant scalar term to every single member of the matrix. All right. So as you see here, if we are multiplying this matrix containing A, B, C, and D, 4 terms, with a constant k, it implies that you have to multiply k to every single term of the matrix: ka, kb, kc, and kd. Clear?
Yes, sir.
Let's quickly try this in this example. Okay, what's the answer for this?
15
15
and -6.
-6. Okay, these are two different terms.
Yes,
Okay,
sir.
here
-7, 14, 0, and 7.
okay, so even this concept is clear.
Yes, sir. Yes.
Okay, let's see this question now. Three matrices are given A, B, and C. All of them have same order, so they can be added or subtracted. Can you quickly tell me what is matrix 1?
So
B plus
B
C.
plus C, that is 1, 1, 4.
B plus C.
Yes, sir. So 1, 1, 1, 4 plus 6 and -2.
So just add the corresponding terms. Means 1 added to 6 and 4 added to -2. And tell the final answer. Like 1 plus 6 is what?
7.
7. So that's all here in the first place.
And
4
then
and
2.
4 and -2.
2.
How much is that? 2. Correct.
Yes, sir.
So it's 7 and 2. Okay. Similarly, what is A minus C then?
-4, 7.
So 2 minus 6 minus 4. 5 minus -2 is 7. Correct?
Yes, sir.
Third one. A plus B and then minus a C. So we add A and B and then subtract C.
Yes.
I think we can do that mentally. Tell them what is the first term here. So when you add the corresponding terms of A and B, it's 2 plus 1, 3. And from 3 you subtract 6.
Yes.
What is 3 minus 6? How much is 3 minus 6?
-3.
-3. That's it. So that's your first term here. Okay. What is this? 5 plus 4?
9.
9 minus
-2.
-2.
Minus. Okay. Yeah. Minus. No. Yeah.
9 minus -2 is how much? 5 plus 4, 9. Then
Yeah.
minus of -2. Minus
Oh,
of minus
okay.
becomes plus.
Plus.
So it's 9 plus 2 is equals to
11.
11. That's it. Clear?
Yes, sir.
Okay, how about this? A minus B plus a C. So in here we first subtract B from A, and to that result we add a C. So A minus B plus C. Again, it's 2 by 1 matrix.
I thought we can add A and C and then subtract it from B.
That's also fine. Yeah, we can do that. There is no problem with that.
Yeah.
Okay. We just go the regular way, like A minus B. So 5 minus 4 is 1. 1 plus -2.
-1.
-1. Okay, adding a -2 is just like subtracting a 2. So it's -1.
So down, no?
Oh,
It will come
that
down.
goes down. Yeah, sorry, my bad. Okay, let's see the top term now. So it's 2 minus 1, that's 1. 1 plus 6 is 7.
7.
7.
Okay, that's the fourth matrix. A minus B plus C. Simple?
Yes, sir.
Okay, let's see the next question. So here in this question, we need to solve for x and y both. I think to find the value of x, we can just use the first row, second term in each of these matrices.
Yes, sir.
You can just say 2 minus. Okay, let's put this x minus 1 inside the bracket. Otherwise, you may end up making mistake with the sign. So it's 2 minus x minus 1 is equals to 7. Okay, let's solve this equation to find the value of x. 2 minus x plus 1, minus of minus is plus, is equals to 7. Okay, therefore 3 minus x is equals to 7. Okay, therefore x is equals to, okay, 7 comes this side, 3 minus 7 minus 4.
Yes, sir.
Similarly, to find the value of y, we can just use the second row, second term. Okay, therefore the equation is y minus 1 minus of minus 3 is equals to 2. So y minus 1 plus 3 is equals to 2. Okay, y plus 2 is equals to 0, or is equals to 2, and therefore y is equals to 2 minus 2, 0. Okay,
Yes, sir.
that's it. Okay, can you quickly just tell me the answer for the next one then? I'll wait for your answer. X is how much?
I got 4,
Okay, x is 4, and then y is?
5.
And Rishabh, what are your answers? X plus a minus 2 is equals to a 2. That means x is equals to 2 plus 2, 4. And therefore y is y and minus 8, y plus minus 8 is equals to minus 3. Therefore y is equals to minus 3 plus 8, which is 5. Clear? Is this fine?
Yes.
Okay, shall we move on to the next question?
Yes, sir.
Let's see this next question. This question says that matrix A is 2 comma 2 minus 3, B is 0 2, C is minus 1 4. Find the matrix X such that it satisfies the condition X plus B is equals to C minus A. So we need to find X, which is a matrix here.
So we can put B that side.
Okay, yes. So that's how we do it. We can just take B to the other side. Therefore, X would be, yeah. So we just need to do this operation. So it's C minus A and a minus B. So therefore, this is 1:2 matrix, correct? And C term minus 1 minus A and minus B term. Okay, the other term, which is C again 4 minus A minus 2. So this is minus 3. 4 minus minus 3 is 4 plus 3 minus 2. 7 minus 2, 5. So that's your final answer. Simple.
Yes, sir.
Given that matrix A is equals to 2 1 3 0, B is 1 1 5 2, C is minus 3 minus 1 0 0, find 2 times A minus 3 times B plus a C. It's 2 times A plus okay, minus 3 times B plus C. I'm just writing the steps, but you can do the calculation directly and tell the answer.
So minus 2 is the first term. So minus 2, 2, minus 9, and so the final answer is minus 2, 2, minus 9, and minus 6.
First term minus 2 looks okay to me. Okay, what about the second term? 2 minus 3 is minus 1, and then a minus 1 again. So I think even the second term is minus 2. Minus 15, minus 9, plus 0, so minus 9. That's correct.
So second term is minus 2, yeah.
Yes. And the last term is minus 6. That's also correct. Okay, Maria, you got the same answer? You understood how to do this?
Yes. Yeah.
If 1, 4, minus 2, 3 plus 2 times m is equals to 3 times 3, 2, 0, minus 3, find the matrix M. Do you understand the question?
Yes, sir.
Yes. So, do I shift the first matrix, the 1, 4, minus 2, 3, to the other side?
That sounds like a good idea.
But where will I put the minus sign? Oh, I'll put, okay, yeah, I'll put it outside.
So it's
The
3,
whole matrix becomes minus.
correct. So 3, 2, 0, minus 3, the whole matrix minus,
So now you
yeah, so I've simplified the RHS, and then to find M, I'm bringing 2 to the other side and dividing the inner matrix with 2. So, yeah,
4, 1,
yeah,
1, minus 6.
yeah, that's your final answer. Okay, so whenever a matrix is missing and a matrix equation is given in terms of M, then best thing to do is bring everything on the other side. Bring all the given matrix on one side, simplify it, and then solve for M. Clear?
So, what if instead of 2m, it was 2 by 3m?
Then
Multiplied 3 into every element?
yeah, if it is 2 by 3m, we cross multiply. This side would be 3 by 2 then.
Yeah.
Okay, so
And then,
after division, you also multiply with 3.
okay, yeah.
I got it.
Yeah.
Okay, tell me your answer then.
Minus 2, 0, minus 1, minus 1.
Oh, A is minus 2, 0.
Minus 1, minus 1.
I,
Yeah, you can verify Maria if it's the same. Then we'll check.
yeah.
You got the same?
I forgot to divide it by 3. Remove the other side. I got the answer.
Okay. Yeah, this is correct. So we'll move on to the next question. Let's try another question. How to solve problems which has identity or unit matrix in them.
So can I tell how?
Yeah, please tell.
So to find M, so it will be
Yeah.
M is equal to
Okay.
so I'm just shifting the 2I that side. So
Okay, very good.
and then it will be plus 2 into 1, 0, 0, 1.
Yeah, very good.
So because they said 2 into 2 matrix, so 2 columns will be.
Yeah.
So I'll just simplify further. So minus 1,
Minus 1.
minus 1, 0, 12, and 5.
Okay, that's it. That's how you do it. Simple.
Yes, sir.
Yes.
even in the next question, we need to do something similar.
For this, it will be 5, and then we have to find m again. So 5m plus 3, then again the same unit matrix 1 0 0 1, and then 3 will get multiplied to 1 and 1, so it will become 3 0 0 3, and then we simplify it.
Okay, so you can just tell me the answer. I think that should be enough.
So m is equal to 5 minus 20 0 minus, oh no, sorry, I forgot to divide it by 5. So m is equal to 1 minus 4 0 and minus 3.
1 minus 4.
1 minus 4 0 minus 3.
Okay, Maria, you can verify it. If both of you got the same answer, we'll just move forward.
Yes.
Okay,
Yeah.
it is the same answer, right?
Yes.
Okay, so till now we saw question based on matrix addition, matrix comparison, matrix subtraction, and obviously multiplication with a scalar. Now we'll move to the next part, which is multiplication of matrix. Okay, so here we have two matrices, which is 2 by 2 matrix. Okay, there are certain rules for matrix multiplication. The first rule is, suppose you're multiplying two matrices. First has order A into B, and the second one has order C into D. So here we know B is what? B is number of column of matrix 1, and C is number of rows of matrix 2. Okay, so in order to multiply these two matrices A and B, it is compulsory the column of A is same as row of B. So these two numbers must be same, then only you can multiply the two matrix. Okay, let's check that out with the example. If we have to multiply matrix A, which is 2 into 3, and this is 3 into 1. Can we multiply these two matrices?
Yes.
Because column of first matrix A is same as row of the second matrix. Right here. So we can multiply A to B. Can we multiply 2 cross 2 matrix with a 2 cross 3 matrix with a 2 cross 3 matrix? Is that possible?
No, sir.
No. Can we multiply 2 cross 3 matrix to a 3 cross 3 matrix?
Yes.
That's
Yes.
possible. Okay. So that means if I have a matrix A, which is 2 cross 3, we can multiply this with another matrix B, which is 3 cross 1. That's allowed. So A into B is possible. Does that also mean that B into A is also possible?
No.
A can multiply with B because column of A is same as rows of B. But does that mean that we can also multiply B to A?
No, sir.
No, right? Because now, see, when you're multiplying B into A, column of B is not same as row of A. So this is not possible. Okay, so what we understand from this is, if A into B is possible, doesn't mean that B is to A is possible. And also, A into B is not equal to B into A, even if they are possible. So multiplying A matrix to a B matrix is different from multiplying B matrix to a matrix. Okay. If we multiply to matrix A into B, obviously they need to satisfy the required condition for multiplication. So here it is satisfying the condition. It means the order A into B and this is C into D. So first condition they're satisfying is B is equal to C. Okay, suppose they multiply to give us a new matrix, let's say M. What is order of this new matrix? Any idea?
So A into D.
A into D. Okay, that's correct. So just quickly to recap, when you multiply A and B, first condition needs to be checked is B is equals to C. Okay, if they're equal, then only they can multiply. If they can multiply, like given that the first condition is satisfied that B is equals to C, order of the final matrix would be A into D. Okay, so for example, if we are multiplying a matrix A having order 1 and 2 with another matrix B having order 2 is to 3, they can multiply because column of A is same as row of B, and order of final C matrix would be, what is order of this final matrix C?
1 into 3.
1 into 3 means row of A into column of B, the corners. All right.
Yes, sir.
We need to multiply two matrices CD with W, X, Y, Z. Okay. So suppose we need to multiply these two matrices, which are both of order 2 cross 2. So they satisfy the basic rule of multiplication, like that the column of A is same as the row of B. So they can be multiplied. And order of final matrix is also 2 cross 2. So it means in final matrix, we will get again 4 terms, as like the parent matrices, which we are multiplying. Now, how we multiply these? In order to get first row, first column term, okay, this is in the new matrix, this is first row, first column. So in order to get that term, you multiply first row of the first matrix with first column of the second matrix. We basically multiply corresponding terms and add them.
Yes, sir.
Correct. So we go like this. First row, first column, we multiply the corresponding terms. Means A with,
W.
okay, and
B with Y.
B with Y and add it. Okay.
Yeah.
Good that you understand this general pattern, but we need to be really careful. Even despite we know this thing, we sometimes make mistake with
Yes.
this. Okay. So then in order to find the first row, second column. Okay, this is first row, second column. We multiply first row with the second column.
Yes, sir. So that's A into X
Okay.
and B in plus B into Z.
So A into X plus B into Z. Correct. Okay, then
Then down same thing, C into W
okay.
and C into and D into Y plus D into Y,
Mm-hmm.
and then C into X plus D into Z.
Very good. So this is how we multiply the two matrices. Okay. So we'll quickly try to do this. Is an easy question.
Yes. So for this also we'll get a 2 into 2 matrix, right?
Correct. Both are 2 cross 2. So we final answer is also 2 into 2 matrix. So AB, we can just write that in a proper order. 4, 1. So A first and B later.
Yes.
1, 0, minus 2 and 1. Okay. So the final, we need to be careful if required, do it in 2 steps. So
Yes.
into 1 and 1 into minus 2. So 4 into 1, 4. 1 into minus 2, minus 2. First row, second column. 4 into 0, 0. Plus 1 into 1, 1. Second row, first column. 2 into 2, 2. 3 into minus 2, minus 6. Second row, second column. 2 into 0, 0. And 3 into 1, 3. Okay, so the final answer is 2. Two terms are therefore 2 and 1, and then 2 minus 6 is minus 4, and 0 plus 3 is 3. Simple.
Yes, sir.
Let's do the next question. B into A. So here we write the B matrix first. 1, 0, minus 2, and 1 multiplied with 4, 1, 2, 3. This is equals to 1 with 4 is 4. 0 with 2 is, it's just a 0.
Yes, sir.
Then first row with second column, so it's 1 into 1, 1 plus 0. Second row with first column, minus 8 plus 2. Second row with the second column, minus 2 plus 3. Okay, so the final answer is 4, 1, minus 6, and 1.
Yes, sir.
Now the third question. A square. How much is A square?
A into A.
Yeah, A into A 2 times.
It's A into A, yeah. I've
So-
seen students doing like this. A square is 16, 1, 4, and 9. Simple.
No, sir.
It's not like that. Okay, don't just square each of the terms. So A square is basically multiplying A matrix with a matrix. So it's A into A matrix. So that is 4, 1, 2, 3. Finding one term, like generally we do it in a sequence, right? So we don't make mistake. Let's not do this in a sequence. Let's fill randomly this term, this term, this term, this term, like this. Okay. So if we want to fill this term here, this is what? Second row, first column, right?
Second.
So here we do second row and first column. Okay. So it's 8 and 6. 8 plus 6, 14. Okay. If you want this term, this is first row, second column. So when you do first row and second column, you get that term. So 4 ones are 4, 3 ones are 3, 4 plus 3, 7. Okay. If you want this term, this is second row, second column. Multiply the corresponding terms. 2 ones are 2, 3 threes are 9. 9 plus 2, 11. And this is first row, first column. 4 fours are 16. 2 ones are 2, 16, 17, 18. That's it.
Yes, sir. Yes, sir.
So here the same equation which you are familiar with last year, we have done so many questions on simultaneous linear equation where you had two equations in terms of x and y. If you observe carefully, this is just the same thing but represented in the matrix form. Okay, so I'll help you solve this quickly. It's very simple. So this is 2 cross 2 matrix and the other one is 2 cross 1 matrix. Okay, 2 and 2 cancel, means they're equal. So the final matrix has to be 2 into 1 order, and that's how it is. So now let's multiply the left hand side. When we multiply the left hand side, okay, we get a 2 plus 1 matrix, means 2 rows and 1 column. Okay, first term is 2 into x plus 5 into y, right?
Yes, sir.
And the second row, first term is 5 into x
And 2 into 1.
plus 2 into y.
Yes, sir.
Okay, which as per this question is equals to minus 7 and 14 matrix.
So now we just have to like write it as an. Oh no.
So now we can compare the terms and say 2x plus 5y is equals to minus 7.
Yes, sir. So simultaneously.
Yeah, this is simultaneous linear equation. Okay, so you're familiar with this kind of equation, right?
Yes, sir.
So we need to just multiply one of the equations. So we can use elimination or substitution method. I think elimination would be better. So we multiply this with 5 and this with minus 2. Okay, 5 2s are 10x plus 25y is equals to minus 35. Second equation is minus 10x minus 4y is equals to minus 28. Now
Yes.
simplifying this two on addition. Yeah, this gets cancelled and this is how much? 21y is equal.
Oh, yes, sir.
21y is equals to, this is again on addition, how much? 63. minus 63. Correct?
Yes.
We just added the two equations. Plus 10x minus 10x gets cancelled. 25y minus 4y is 21y and minus 6. So this is minus 63 divided by 21. That is minus. Okay, we can plug this value in one of the equation, preferably the first one. 2x plus 5y is equals to 5 into minus 3 is minus 15. Is equal to
Minus 7.
8. Yeah, minus 7 plus 15 is plus 8, and x is equals to. That's it.
Yes.
Okay. So in this equation, actually the equation was given in matrix form and we converted it to this form, to the equation form, and then simplified it. Okay.
Yes, sir.
Okay. Thank you and bye for now.
One.
Yes, sir. Thank you.